Now, we want to access and configure our SoftEther VPN server. In the previous video, we had connected to the server using an SSH client, and everything we did was using commands on the Linux terminal. Well, configuring the VPN server to accept connections is actually possible using the same terminal by issuing a bunch of commands and creating certain initialization scripts like we did earlier. But I had promised that we'll be demonstrating in this course from the perspective of beginners. So I'm going to use a Windows tool with a graphical user interface to achieve this, as Windows machines are of course available to most people. This video is sponsored by Trashcoms, my number one choice for high-speed, unlimited bandwidth, and very affordable VPS hosting, which of course is where we have the VPN server we're using in this demonstration hosted. So again, I'll open up our browser, head out to www.softether-download.com. We'll leave the first field selected as SoftEther VPN freeware, then select the component. We'll choose SoftEther VPN Server Manager for Windows. Platform, we choose Windows. The CPU, of course, for me is Intel x86-64 for 64-bit operating systems. Then click the first RTM version here and download. When that is done, you double-click the downloaded file to launch the installer. Then proceed. Accept the security prompt. Then next. Then here we choose the component we want to install. We don't need a VPN server, we don't need a bridge, so we settle for the third option, the VPN Server Manager. Click Next, agree to terms, Next, Next, leave the installation path at the default directory as C, then Next to install. When that is done, we leave this box selected that says Start the VPN Manager, and then we click Finish. Alright, now we see the window opened. The next thing we are going to do is click on New Setting. And when we do, it prompts us to enter the connection name. This could be anything that we would like to remember this VPN server with. So let's call it VPN1. Then for the host name, we'll have to impute the IP address of our VPS, where we had installed a VPN server in the previous video. So we copy that from our mail or notepad, wherever you saved it. Paste it in the hostname field. Leave the TCP port at 443, the standard SSL port. Leave the password blank, and everything else as it is, and hit OK. Now, we see VPN1 has been added to our list. Remember, for our connection to the VPN server to be successful, the TCP port 443 must be open on the server side. Being the standard port for SSL, it is usually open on most standard VPS, and definitely it is for the provider I'm demonstrating with. If for some reason that port is blocked by default by your VPS provider, you will need to ensure you connect your server via SSH and open it before proceeding to the next stage. I've equally provided the command for doing that in the resources of this video. So we select VPN1 and hit connect. Being our first connection to this server, it will prompt us to set an admin password. We'll go ahead and do that. Be sure to remember what password you set at this stage. So set the new password, repeat it, and hit OK. Then we wait for some further automatic prompts. SoftEther has tons of features and configuration options, but you want to be really careful about what options you make changes to. By default, the SoftEther Server Manager for Windows guides you through the common settings required for your VPN server to function, which is why I picked it for you. So I'd rather you stick to that at this stage. Now you select the Remote Access VPN, Site-to-Site VPN, and then select the role of this VPN server to be one that accepts connections from other sites. Hit Next, confirm with a yes. Now it asks you for the name of the virtual hub. You can leave that the way it is, as VPN. Hit OK. Now it asks you for the dynamic DNS host name. You may wish to change this to something you can remember, or leave it the way it is. What is this function exactly for? Before now, you cannot really set up a publicly accessible VPN server on a machine without a fixed public IP, because users will need to specify this static IP when connecting to your VPN server. SoftEther has changed all of that. SoftEther VPN server has the built-in dynamic DNS and NAT traversal functions. So static IP addresses are not exactly required to set up VPN server. The dynamic DNS function assigns a worldwide unique identifier on your SoftEther VPN server. Your global IP address of SoftEther VPN server will follow dynamic IP address changes. If the IP address of SoftEther VPN server suddenly changed, the IP address record which is registered to the dynamic DNS hostname changes automatically and immediately. So a VPN client user can specify the dynamic DNS hostname as the destination VPN server's hostname instead of the IP address. VPN client and VPN bridges can keep stable connections to your SoftEther VPN server even if the server-side internet connection is not on a static IP address. So we can change that to anything we fancy, provided it has not been taken by someone else. Set hostname and hit OK. Then click Exit. We get yet another prompt asking us if we want to enable L2TP with IPsec. Of course, we want this protocol enabled, as that is what most phones, tablets, and some computers will be using to connect to our server. Now, for this protocol, we have two models. I had mentioned earlier that for proper encryption, L2TP is often paired with IPsec, with IPsec serving to provide encryption. SoftEther allows you to enable L2TP with IPsec as well as raw L2TP without encryption, which would be just okay for users who have no real encryption needs, who just want their traffic tunneled or simply to hide their IP. So I will enable both. Leave the primary virtual hub created as default. And then also I have the option to enable Ether IP server function for site-to-site VPN. This will allow compatible routers to connect to this server's virtual hub and establish bridging or layer 2 connections, depending on your use case. This is optional. For me, I will leave it unchecked. Then for the L2TP IPsec protocol, we'll need a pre-shared key or secret, which your users will have to specify when making a connection. This is usually around 8 ASCII characters. So I will say VPN keys, hit OK. Next, I find another prompt for VPN Azure. NAT transversal functions works with most NATs and firewalls. However, some restricted firewalls cannot pass NAT traversal packets. We'll talk about NAT in a bit. With the VPN Azure activated, all VPN connecting requests from VPN client or VPN bridge will be relayed through the VPN Azure cloud service operated by SoftEther VPN project for free of charge. The principle of VPN Azure is very simple. The SoftEther VPN server behind a firewall always keeps a TCP-based connection towards a VPN Azure relay server. It is permitted automatically by the firewall because the direction of the initial connection is from inside to outside. The firewall treats such packets as trusted. VPN client or VPN bridge requests the appropriate VPN Azure relay server to connect to the VPN server. The VPN Azure relay server will relay the connection request to the SoftEther VPN server. Then, SoftEther VPN server will establish the UDP-based VPN tunnel between the VPN server and the VPN client or VPN bridge. After the UDP-based link has been established, the VPN relay server doesn't relay the payloads of VPN tunnel. Amazing design, I must say. So I will select the radio button for enable and click OK. Now I am prompted to create a user. This user is not an admin like we created earlier. This is a VPN client. This account will be valid for establishing VPN client to server connections from other devices to this server. So I hit create user, then I'll specify a username. In my case, I will say Iman1. We have a field for name, user group, and a couple of other things. I'll leave those blank. They don't really matter for our purpose at this point. Of course, you have the option to set expiry, security policy for this user, and all of that. But since we'll be managing our users externally, this is not exactly an item for us. We'll go ahead and set the password. Then in the authentication type, we will leave it as selected, password authentication. SoftEther VPN server allows for a wide range of authentication methods, including anonymous authentication, which I surely don't recommend. In this course, we'll be using only password-based authentication and radius authentication. We hit OK, and our user has now been added. Again, we see it popping up the list of users in this virtual hub. Of course, we have just one added, which is OK, for what we want to test out. We exit, close. Now, we can see the server is listening and ready to accept incoming connections. But we are not done just yet, as users who manage to connect to this server will still not be able to access the internet through it. Something is still missing, and that is where the NAT we spoke about earlier comes in. NAT in this context stands for Network Address Translation. It's a way to map multiple local private addresses to a public one before transferring the information. As it stands now, our server has one public IPv4 address assigned to us by our VPS provider. We cannot possibly assign this public address to all devices connecting to this VPN server. Yet, we want them to access the internet through it. The NAT and DHCP server function will enable us to assign private IP addresses to our VPN client while routing the traffic via the singular public IP of our VPN server. This is similar to what happens with your broadband Wi-Fi router at home. Your ISP assigns you one, usually dynamic IP address at a time. But you have a bunch of devices like phones, laptops, and maybe TV sets connected to the router. Well, your router does the job of assigning private IP addresses to each of these devices while representing all of those devices with one unique IP address on the public internet. We have a feature in SoftEther that virtualizes this same job done by your router, and we need to enable it for our setup to be complete. So we click on the VPN hub, select Manage Virtual Hub, then go to Virtual NAT and Virtual DHCP server, and we click on Enable Secure NAT. Hit OK. Then go to Secure NAT Configuration. We see the MAC address of the virtual network interface. We see the IP addresses, which is also the same as the gateway. Now you see the subnet masks, 255.255.255.0. If you still remember our lesson on subnetting, you can quickly tell that this gives us about 256 IP addresses with 254 hosts or usable IP addresses, the gateway and broadcast address having taken up 2 IP address space. Now, on the right-hand side, you see the virtual DHCP server functions. By default, SoftEther distributes from 192.168.30.10 to 192.168.30.200. which is about 190 hosts or usable IPs. Feel free to configure this according to the number of connected users or sessions that you want this VPN server to handle at a time. You can leave the default gateway as the interface IP. We can leave the primary DNS server address as same, and then we may add a secondary one. Usually I like to use Google's DNS address at 8.8.8.8 as my secondary DNS. Now leave everything else the way they are. Click OK. Exit. Exit yet again. Now, one more thing before we start the process of connecting the first VPN client. If you remember, I had mentioned that SoftEther VPN allows us to easily add OpenVPN functionality to this server alongside other protocols. So we'll go ahead and click on the OpenVPN/MSSSTP setting. By default, OpenVPN listens on TCP port 443 and UDP port 1194. We can change this to a custom port we desire or leave it the way it is. I generally prefer to leave it the same way. Then, hit generate a sample configuration file for OpenVPN clients. Wait for the file to be generated. Then when prompted, we save it with a file name of our choice. In my case, I will say Iman VPN server 1, change destination to desktop for easy reach, and save. Ask me if I want to open the configuration file now. Well, not just yet, so I'll say no. Hit OK and exit. Now, our VPN server is all set. In the subsequent videos, we'll be setting up connections from our Windows, macOS, iOS, and Android devices to this server using the various protocols that we have enabled.